Hi, I'm Craig Roller from Sandfly Security. Today I'm going to demonstrate how to use Sandfly's Agentless Linux security platform to automatically monitor a Raspberry Pi running the ARM processor. But we also work on embedded devices running MIPS processors as well. Now the thing is, I love Raspberry Pis. For $30, they're an extremely powerful platform that gives you great capability in a very small package. But the reason I don't like them is because a lot of times they're plugged in with default credentials into networks, and that allows attackers a very easy way to get access into a very powerful system with very little chance of being seen. This happened a few years ago actually at NASA with someone plugged in a $30 Raspberry Pi and resulted in a massive compromise of their network. So while I do love them, I understand they need to be watched. Sandfly in this case is very unique because being an agentless platform, we don't leave anything permanently running on an embedded system. And this is actually an extremely important point because a lot of embedded devices don't actually want to have anything running on them, and there's no way to maintain that persistence anyway. So in this case, what we're going to do is I plugged in the Raspberry Pi. It's going to boot up and it's going to pick a DHCP address. So I actually don't know where it is. We're going to go to our add host. And I'm going to show you how quickly we could find these devices. I'm going to do a net block here. I know it's in this IP address range of 192.168.1.0. I'm going to have it scan the class C. I'm going to put in a tag here of just simply Pi. We know we have an existing credential that could work. This is going to allow us SSH access to take a look around. We don't have a jump host because we're internal inside behind a firewall. And we're going to hit finish. Now at this point, Sandfly is going to connect to these systems, and we're already starting to get some results. These are inactive hosts here, but I'm going to select active only. I'm going to hit refresh. And in a second or two, we're going to see actually this Raspberry Pi is going to be discovered, logged into, fully inventoried as to what it actually is, and we're going to have that information at our fingertips. And there it is. So in a few seconds, what happened here is we connected that host, we pushed over our agentless system to do a forensic analysis of the box. We pulled over information such as the ARM processor type that's here, the kernel information, as well as extensive raw host information as well. If you want to pour this JSON into a SIEM or log monitoring tool of your choice, you can go ahead and do that. But at this point, we're ready to begin scanning. So we're going to kick off a security scan. I'm going to select our host. I'm then going to select the security scans I'm going to run. In this case, we're going to run all the checks that we want to do. And I'm going to hit finish. And at this point now, we're connecting to that system agentlessly. We're going to assess whether or not there's anything going on in that box that's suspicious, and we're going to report back results in a few minutes. So I'm going to pause the video, and we're going to come back in a second or two after this is done. Right, so we completed the full security sweep of this embedded device running on the Raspberry Pi. And now we have some results. Clicking here is going to take us to that system. We see our IP address, 192.168.1.123. That was automatically discovered when we did a sweep of that block. The host name is simply called Raspberry Pi. We're going to click on that, and we have 3 alerts. Process port listening on TCP suspicious. And it looks like here we have 2 bind shell backdoors running Python. So we click on any one of these, and we're going to get full information about what it is we saw. We have the full MITRE attack information, so you can click on any one of these and get the MITRE attack database. But the other thing that's interesting about it too is we give you kind of a plain text description of what's going on. There's a process named Python2 with a PID 845, and it's operating with a command line here that looks extremely suspicious. We could see here that this command line definitely looks like that they're doing something here they shouldn't be. We can also click on the raw data information, and the raw data is going to show us all the information about that particular attack that's available. Other things here that are going to be interesting as well is we're going to show you in this case here, this is running as a Python backdoor. So you're actually going to get the full backdoor information, such as the port is listening on and anyone who's actually connected to it. So that's basically it in a nutshell. That's how quick and easy you can get monitoring of your embedded devices running Linux. We have customers who use us to monitor embedded devices. We're a very good platform for that solution because we don't have to leave anything permanently running on the endpoints. And on an embedded device, that's very important because compatibility issues are a very big deal, and you don't want to brick the things, that's for sure. And Sandfly has an extremely good reputation of being highly reliable with very low impacts. So if you have embedded devices, I recommend you watch them, of course. Sandfly's agentless approach is a great way to do that. You're happy and welcome to get a free license to try Sandfly out, up to 500 hosts. We also have additional features as well that can help you get control of your Linux situation and handle any incidents that you might have. So thanks again for watching the video. I'm Craig Rowland, and please check out our website for more information about handling Linux incident and security. Thanks again.